In this short lesson, we're just going to take a look at how we deal with transition metals. We know with the A group elements, which are the S and P blocks, we can get their charge of the ions just by looking at what column they're in, because if it's a 1A element, it has 1 electron in the s orbital, it'll give it away to form a positive ion or a cation. 2s, it'll give 2 electrons away. 2s, 2p, then it can give away 3 or 5 or 6, really, if it's a metal. So transition metals, though, they don't just have the s orbitals to worry about. They also have the s and the d orbital. Now the d orbital is actually a lower energy level, right? We have the 4s and then the 3d, but that d orbital does have electrons in it, and they will be on the outside once those s electrons are gone, which means some of the transition metals can do some things like form multiple ions. So copper actually can be copper 1, which we write as Roman numeral 1, or it can be copper 2, which we write with a Roman numeral 2. And the only difference between these is copper 1 is a 1 plus ion and copper 2 is a 2 plus ion. Because those electrons are available in the d orbital, it can form either of these ions. Iron is similar. It can be iron 2 plus or iron 3 plus. Okay? And so we use the Roman numeral to show the charge. So this is iron 2, and this is iron 3. But we're not limited to only a +1, +2, or +3. We actually do have things that have a +5, +6 charge on them. Metals will form positive ions. The hardest thing about this is sometimes students want to tell me that the Roman numeral has something to do with the subscript, but it doesn't. So when I say iron oxide, I can't just say that. I need to be specific about it. Am I talking about iron 2 oxide? Or am I talking about iron 3 oxide? Well, if I'm talking about iron 2 oxide, then I have a different chemical formula, because iron 2 oxide is Fe with a 2 plus, oxygen is always a 2 minus, that gets me FeO, right, a 1-to-1 ratio to get a neutral compound, whereas iron 3 is Fe3 plus, O2 minus, so now I have Fe2 O3, so I have a 2 to 3 ratio because I need the +6 to cancel the -6. So these two things are the chemical formulas, respectively, for iron 2 oxide and iron 3 oxide. And when you name something with a transition metal in it, you do put that Roman numeral there. It tells the charge of the ion in the compound. And if I give you a chemical formula and want you to come up with a name, you should be able to do that. So if I say CrF6, well, let's think about what that means. That means I have 1 chromium, and it's a metal, and I have 6 fluorines. What do I know about fluorine? Well, fluorine has a 1 minus charge. If I have 6 of them, that's 6 minuses, which means I need 6 plus, which must mean chromium is actually a 6 plus ion. I have Cr6 plus, and then I have F minus, and that gets me my CrF6 formula. So what is this thing called? Well, chromium has a 6 plus charge on it. That's chromium 6. Remember, use your Vi, Roman numeral, fluoride. So treat it just like in any other ionic compound, except that when it's a transition metal, we use those Roman numerals to give us the charge.